I'm Nona, and I'm here to tell you something about cosplay electronics, because I know that this topic is like a really big mystery for most of the cosplayers, and everyone thinks it's really, really hard stuff, and it's not like a common person wouldn't be able to do anything like this, but that's totally not true. So at the beginning, I'd like to tell you something about what can you do with it. So most common thing, and something you probably have already seen, is some LED lighting. You can place lighting LEDs in your costumes just to glow it up, so it looks like magic or some sci-fi stuff. In the picture you can see one of my older works, probably my most complicated build ever. You can see at the back that I have some window right here. Oh. Right here is a window that I lit with some LED strips. Here I had a plates that were turning with servo mechanisms. So if you're brave enough, you can place some rotating parts on your cosplay and it looks like it's really moving. If you are more of a mechanic, then you can create functional mechanisms, so like guns that will like spruce up with some additional parts that were originally inside of it. And then you can modify existing devices for your use. The most common example of that is for using this to create smoke machines that you can use in your cosplays. Right. The very basics of everything. This is something I say at every panel when I start. I like to say that electrical current is like water, and it flows in the cables just like water. So if you look at the schematic right here, here's the battery. It's the source of the water, and then it flows right here. Here's the switch. If the cord is broken, the water cannot flow, so nothing will turn on. But if you turn the switch on, the current will flow, light up the LED, and then go back here. The resistor is used to stop damn it. If the flow of the water is too strong, then you will damage your light bulb, let's say. So the resistor is used to somehow stop the flow, to limit it, and nothing gets damaged in the way. Sorry for that. It's like my first time speaking in foreign country in English and giving a speech like that. So if you imagine that it's like this big river, and taking all the physics aside, you just don't need to think about it at all if you are just placing some lights in your cosplay. You need to keep in mind just really basic stuff. Most of the devices, all of them, has the plus side and the minus side of it. Pluses are connected to pluses, as here you can see, and the minuses are connected to minuses, so to speak, ground, or the zero potential side. And then magically everything works now. Do not absolutely do not connect the pluses with the minuses, because that will create a short circuit and everything will burn. So if you connect both sides of the battery without anything inside of the circuit, you will just burn it and it can explode, so don't do it. And then if you buy something, some LEDs, some devices, check what's the nominal voltage of the device, so you won't connect it to the battery that has higher voltage than the device can handle, so it won't break. And if you're wondering what the voltage is, well, is the difference between the potential between the plus and the zero level, and the current is how many of the, let's say, those current particles are coming with from the battery in your circuit. Now, something you will need to start tinkering with electronics. At first, if you don't want to play with some soldering iron, which is this one, and it looks dangerous, and it is quite dangerous as it's quite hot, and maybe you use it before to just burn some patterns in your foam, maybe. You can use a breadboard. You can just stick some LEDs, stick some battery connections and cables and see if this works before you will just assemble everything together. Here you have some LEDs, here you have some resistors, cables look like this. If you don't have soldering iron, then don't worry. For cosplay uses, using hot glue is really okay, because you can just twist the wires together, and as long as it sticks together, hot glue works as an insulator, so nothing will happen. The current will flow without problems. So you can just put some really basic electronics without worries that you don't have any special equipment. Tweezers like those can be useful just to cut everything, but you can use regular scissors. This creepy guy is used to just hold everything in place while you use both of your hands soldering. And this is a multimeter, and I would say it's more for intermediate users, so you can just check the voltages, if everything flows right, or if you have short circuit in your circuit, then you can use it. Now, about the power supplies, because people usually don't know what to choose, those are just batteries. And there are various types of batteries. You can use alkaline or lithium batteries, and there are those ones, just the regular ones that you can buy at your shops. They give voltages of 1.5 volts, and you can use them in some sockets where you can put more of them. And if you put more of them, then it just sums up to some bigger values. Then if you want something that can be recharged, because those regular shop batteries cannot, you can buy some LiPo or Li-ion rechargeable batteries and battery packs. For those, you can they usually look a little bit different. This one is a battery that is used in laptops. This one looks similar, like some battery packs look. You need to search how the shape will look like, so you will know whether you can fit it in your costume or not. And then if you enhance a bit your USB cable, you can use power banks as well, as they have some good capacity and can give up the current as well. Check the voltages of your batteries and then check how much of the current capacity it has, because various batteries have various current capacity, and some don't give out the current as others. For example, those batteries will cause the LED strips, let's say. Let's talk about LED strips. I will show you how it looks in a second. These ones will make the light much more brighter than, for example, those ones. This one is 9-volt battery, and even though it's much bigger, it works a little bit worse. However, no, however is a bad word. Actually, this one will hold up and light your props much longer than this one. I'm not sure that this one, those coin cell batteries, will work similarly long. You just need to look up which one will work best, and I recommend personally just to leave your prop on to see how long it will take for it to drain the battery. So you won't be left on the convention without with the prop that is not usable because your battery is dead suddenly. Right. So now let's this little thing is the most common thing and most cheap one you can put in your costume. You can buy it in many colors and in many sizes. If you need a small point light, it will be perfect. However, if you need some more area to light up, then it won't be as good because the light is really, really, really small. Then each LED color needs to be supplied with different voltage. So here I marked which colors are which voltage. So for example, white, blue, and green are suitable for 3.3 volts. So the single coin battery will work fine with them. Orange or yellow and red are more 2 volts. So using them with coin battery will require a resistor, as I said before, to limit the current so the LED won't get damaged. And the pink one is 3.5, so the coin cell battery might not be enough. This one is perfect for just trying everything up, because even if you break them or damage them, then it's so cheap that you won't cry a lot that it burned. And I recommend actually to burn a LED. For example, if you connect some of those to a 9-volt battery, then it will just go poof and the smoke will come out of it. And diodes are so clever or not so clever. They have the polarity, so the longer leg is the plus and the shorter leg is the minus. If you connect, normally you would connect it in a way that plus goes to plus of the battery and minus goes to the minus of the battery, so then everything works and it lights up. But if you connect it in a different way, nothing wrong happens. It just won't light up, but it's because it stops the current from flowing. Nothing happens, you can just undo it and it will work just fine. Those LEDs require resistors if your battery voltage is too high. So without any physical equations, because I know that no one will remember them at all, you can just type in Google your, it's called LED calculator. It will pop up in your search. So here's source voltage is something you have from your battery. So for example, if you have a 9-volt battery, you would type here 9. Diode forward voltage is that supply voltage of the LED, depending on the color. So for example, I typed 2 as for the red diode. And diode forward current is 20 milliamps always. It's just characteristics for all the LED diodes that that's how much of a current it takes to glow. And I got 390 ohms, and that's the resistor you just buy from the store. Put in the circuit like in the beginning. Right here. It doesn't matter if you put it behind the LED or here, it will work as well. And hopefully it won't break if you connect to high voltage. Now, something I personally love, because those single LED diodes are just really, really small, and the resistors are really, you have to count them and you have to put it in the circuit. It's troublesome. I love using LED strips. It's basically prepared circuits with the LEDs, but the resistors are already there. You don't need to worry about them. There are models that can be used with 12 volts or 5 volts. However, they work perfectly fine with those big square 9 volts battery. That's how I usually use them. You can cut the LED strip within 3 to 5 centimeters segments. The light is really, really intense, so it looks really nice. Let me show you. Those are my works that I put the LED strips inside. And it comes with variety of colors, similar to usual LEDs. However, my trick to placing those in props is just using some colored windows. So I don't buy a colored LED strip. I just place it behind a window that is painted with some transparent paint, or I use some foils that can be glued on the plexiglass, and use white LED strips. Also, sorry, can I get some water? Is it for? I will have a drink and I will be back in a second. Sorry, that's needed so I don't start coughing and dying. LED strips also comes in RGB model, so you can change the output color of the LED strip. And basically it works like pixels on your screen from computer. It can light in every possible color that is made out of red, blue, and green diodes. Connection of the LED strip is really, 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 really easy because it has that plus and minus pad. You just solder some wires here, and then connect it to the battery, and then, well, magically it just starts glowing. So, next. For those that would love to see something spinning and something moving, here are DC motors. This little fella has, basically it's just LED that spins. It has those two cables, one is red, one is blue. Blue is usually the same as black, so treat it like a minus. If you connect the right voltage, usually 5 or 12 volts, this shaft will start to spin. If you glue anything, it can be glued. You don't need to use some correct mechanical equipment that usually people put stuff to the motors. You can just hot glue stuff on it and it will start spinning. It spins really, really, really fast. If you connect it to the lower voltage, then it should be connected to, then it might get slower. However, normally you would need some gear shaft to make it spin slowly and nicely. And the torque, which is, let's say, a force that the motor can give to your piece, is relatively small, so no heavy stuff on it. Then, those are servo motors. Those are more sophisticated DC motors because inside there is nothing more than this, but it has a gear shaft, which is here, and the microcontroller that controls how exactly it spins. Interesting thing about this is that it can sweep only a set degrees, so it's not just rotating in circles. For example, those plates. Oh, yes. How big is this? It depends. The smallest ones are like this, and I saw that big ones. Right. So the MCU, which is the microcontroller, controls how it sweeps. Most of them is 180 degrees. I saw some that, hi. I saw ones that were 270, and some of those are marketed and advertised as 360, but I think it was a lie. I got cheated on that one. so just assume that they have that limited motion. They sweep slowly and steadily, and the torque, which is that force that you can apply to think that it's spin with this, is much more bigger. So you can actually place some heavy things on it. Those plates I had on my hips on that program, Camille cosplay, I showed you at the beginning, were quite heavy. And actually placing them in a weird position caused even those servos to stutter. If you put something too heavy, the motor might get stuttering and it won't look so good And to use those, you need to connect it to some additional microcontroller that will tell this motor how to behave in the way you want. And this microcontroller can be found in Arduino. This is where stuff is getting a little bit more complicated, but also no. This is, as I stated here, the brain of the circuit. You can just plug it to the PC, and then you plug it in with the USB cable, and you upload the code on it. There are tons of examples that you can use, and you can write your own stuff. Right, so what you can see here are some gold pin connectors, and here you can connect all those stuff I said before. So to make it work, you need to supply it. So the voltage in connector, which can be found here on the power segment. Here you supply the voltage for the whole component, so it can actually work. It's treated like a little computer, so you can somehow turn it on. You can connect something from 7 to 12 volts here, and it will transform the voltage into 5, so it's more usable. It can also transform the input voltage into 3.3, so it's more suitable for powering the batteries, for the LEDs I meant, sorry. And those you can find here, so you can just power up some other devices from those pins. And G and D, which is ground, so to speak, the minus pins. You can find it here, and you can find it here. It's all the same. If you connect it to one point, then it's here as well. Then you have digital inputs and outputs, which are there. When you program the Arduino, you state whether this pin is input or output. So basically, you decide whether Arduino sets if it supplies some voltage or not, or whether you check if something from the outside is giving voltage or not. And analog inputs are those pins that you can source analog signals. So if you have like sensors or some kind of microphones, you can just get the signals and then use it in this processor. But well, I had some ideas for using sensors in my cosplays, but it gets really sophisticated there. If it comes to programming, here's the example that you can find in Arduino Ide. Ide is like environment you can write your codes in, and Arduino has its own. In general, the programming language is C or C++, but for me it's more like using the predefined blocks that can be used So it's not like you don't need to be a really good C or C++ programmer to do it. You just need to learn the basic functions that this application just gives. And you can find really tons of examples in internet, in the IDE itself. And I'd like to somehow explain how it works. Basically, you have two segments of the program. One is the setup, where you just write whether the digital inputs or analog inputs, how do you want to use them. So, for example, here you write that the pin 13 will be an output. Pin 13 is right here, but it's also connected to a special diode that is placed somewhere around, doesn't matter. So you declare that this pin will be the output, and if you want it to be an input, you just write it's an input. And then after the setup, you have that loop function. It's called the loop because the program here will be executed in a loop over and over and over and over and over again. This one only executes once at the beginning when you power up the device. And here digital write means that you set up the pin 13 into a high state, so it supplies voltage, causing the LED that is connected to this pin to glow. Then you have some delay, which means that the processor waits and just simply does nothing. It's in milliseconds, so you have 1,000 milliseconds. It's like a second. And then you set the pin 13 to a low state, which turns the LED off. And then waits again a second, and it goes back here. So this one just blinks the LED. It's like the most basic stuff you can get. And as for the syntax, typical for C++ programming, you have those brackets you need to remember about and all those colons. But that's just something you have to look up. As for buying the electronics, you need to check your local component stores. I think that's the best idea, just to go to the shop and ask the person who works there about some advices. If you need any help, he will guide you. If you need to know what resistor will be best for your LED, then he will calculate it for you, hopefully. Then, if you just freak out at the thought that some other guy might be looking at you while you're buying this stuff, then just check what you have available if it comes to online stores. Most of the stores can supply you with all you need for the cosplay stuff. And then AliExpress, of course, because it's cheap. Right. AliExpress and auction sites. Many people like to buy like branded stuff. For example, if it comes to, oh no, what have I done? Wrong side. Thank you. So, for example, if it comes to LED strips, Adafruit is like the leading company for those, and they have really, really crazy stuff that you can buy and that you can use with Arduino. It's like all plug and play, and it's, of course, quite comfortable to use it and just not think about the rest, but it's quite expensive as it's branded and they make stuff that's branded, so you have to pay for the brand. But you can buy some cheap equivalents for the LED strips and all this stuff from Chinese people, because they make a lot of bootleg stuff that can be really, really as good as those. Same with Arduino, because for the original Arduino stuff, you have to pay really, really lots of dollars, which is quite surprising. And it is open source project. I mean, the schematics for it are available online. So first stuff, you can build it at home, really. And then there are really, really cheap equivalents available in those auction sites. So it just won't ruin your budget, and if you're a beginner and you just want to try out stuff, then it's available for everyone. Now there's some time for questions, because you might have tons of them, and I hope you will have tons of them, because we have so much time to the end of the panel. Yeah. Oh, that's not the. I don't know. I somehow practiced a lot, and ended up not looking like potato at the conventions.
What kind of wire do you recommend for circuits?
If it comes to wires, it would be nice to use something that is not super thick, so you can hide it inside of your costume. Usually I buy the thinnest I can get, and it's like 1/2 millimeter diameter, I guess. And for the breadboards, you can buy cables that have metal pins on both sides, so you can just plug it into the holes, and it's all easy and convenient.
Where do you buy your Arduino board?
Arduino? I buy mine at Polish auction site. However, it was totally fine to find some in my local stores. Like, some of them has it in assortment. Any more? Please. Oh, yes.
Hi, so my question is that the cosplay you showed in the beginning, just the electronics part, how expensive was it to put it together, and how much hours did you spend on it?
The whole cosplay, or just...
Just the electronics
just
part.
Electronics. Oh my God. It wasn't that bad. Let me think. It wasn't really expensive, as the LED strips are cheap and the Arduino clones are cheap. I think I made it below 20 euros. I don't want to. I'm not the expert on the economics, so I might be mistaken about that. But it wasn't like, oh my God, that's so much money. Oh, okay. Servo Motors are expensive, no matter what. Those were expensive, and I had 2 of them in my hip, so that was something. And setting it up wasn't really long, as I have experience in electronics. In sort of, I studied mechatronics, and now I'm working as hardware engineer, so it's like common bread for me. some day or two just to solder everything.
Do you have any recommendation how to fix in place the electronics and how to hide the parts that are not supposed to show? Like an Arduino or even a servo motor.
So how to hide the parts and
How to hide and how to fix in place.
fix in place. The best solution is to use the solution that the mechanics would use. So just fixing it in a way it cannot vibrate or cannot sweep to the sides. So some screws and stuff. But for most of the users, if you are just placing it all in EVA foam, then just use a lot of hot glue around it, and it will be just fine as long as it doesn't show anything anywhere in front of it, so no one can see. As for hiding, well, you have to be creative and think about it before you create your whole prop. So you just prepare some hiding spots for batteries, for the cables, so you won't end up in a situation when you create the whole prop and it's all nice and stuff, and then I would use some LEDs in it, and then you put the LED and think, oh, I need to put the battery somewhere, and I don't know where, and now, oh, I need to split my prop in half and make a big hole in it.
Thank you.
And you have tutorials about this project?
Could you repeat?
You have tutorials about this project?
I can't get the last word.
About this project?
Okay. The tutorials about the projects. Well, yes. People that create stuff for Arduino, the community is great. They are fantastic people because they document all the stuff they do. So you can usually you can find the whole tutorial step by step with pictures, what they used, what cost was it. The code is also published. The circuit schematic is also published, so you can find it. And they wrote what the way was, so you can just use it for your own projects and to learn from them.
So question is, follow-up, do you have any tutorials on how to, like, the mechanical parts of it? So, for example, if you use a servo or a simple electric motor, and then how to, like, design the prop around it so that it fits and so on?
Sadly, not really. I didn't stumble upon any solid ones. If you need something specific that maybe is popular, like, I don't know, maybe some cosplayer made some movable prop for some popular character, then you might find the tutorial for it. But in general, mechanics isn't that popular. People just don't do it. So it's hard, sorry.
Okay, thanks.
And I didn't prepare anything myself, sorry. Anyone? Could it be? Is that it? Oh! Oh, I think she didn't want to speak. Oh, no. Okay, so I guess it. No, it's coming.
Thank you. So you talked about smoking machines at the beginning.
Yes.
How those work?
How?
Besides getting a smoking machine, how? I think those are more difficult than some LEDs or motors.
Well, you have definitely find tutorials for them, so it's a lot easier. My experience with those were not so easy and not so well because I damaged my ASICs. Usually, you made the smoke machines out of ASICs, and they can be pretty dangerous as the stuff is getting hot and you can burn yourself on your or the stuff can get really on fire. So I damaged mine, and it actually started to burn with the real flames, and I just dropped the idea that I want to do this. But it generally requires to only attach some liquid pumps to ASIC, and then just turn the ASICs on, so the pump simulates how you would breathe and inhale the smoke, so that's how the smoke gets outside. I think that using the recommended parts would make it a lot easier because I just took someone's old ASIC and it wasn't as modifiable to do it. Well, it can be difficult, but in a way that it just might be dangerous if you're not cautious enough when you do this. But it's totally possible, and if you can just follow the tutorials, then I think you will manage.
Thank you.